regression analysis, I am going to be discussing factors that impact employee salaries from one company. So, what actually contributes to a person's pay? In the model that I will be using, we'll be looking at gender, previous experience, education, time on the job, and beginning salary. I think that this regression will be a reliable way to isolate the contributing factors to a person's pay. More specifically, I want to take a look at the gender wage gap. We've all heard it before, but is it true? Are women paid less because they are women? One meta-analysis that I found claims that there is still a 20% unexplained mean gap between the two genders. I predict that the regression analysis will observe just that, that there will be a relationship between gender and pay, among the other factors. So the data that I'm using I found at webster.edu. It is a sample size of 474 employees. My dependent variable, the variable that I am measuring, is current salary. And the explanatory variables, my X variables, are gender, which will be my binary dummy variable, education, beginning salary, time on the job, and previous experience. Confidence level is, of course, going to be set at 95%. So I have some predictions on what the coefficients of my analysis will be. I believe that gender will be a negative coefficient, meaning that going from male to female will cause a decrease in my current salary. And the other coefficients I predict will be positive. So more education, higher beginning salary, more time on the job, and more previous experience will cause my current salary to increase. So I took each of the Y variables and compared them to my each of my X variables and compared them to my Y variable of current salary, and ran scatter plots with a trend line. The one on the left is the correlation between education and current salary. As you can see, it is upward sloping, meaning there is a positive relationship between the two. And on the right, we have correlation between beginning salary and current salary. One thing I found pretty interesting about this is that the residuals between the actual points and my trend line are very small. They're all clustered around that trend line, meaning that there is a close relationship between beginning and current salary. Next, we have correlation between job time and current salary, and correlation between previous experience and current salary. Now, I was a little confused about the units that my data series was using. I believe that it is months on the job. So our highest was 98, our lowest was 64 months. And it's caused my graph to be kind of clustered on the right. It's a little hard to read. But if you can see the trend line, it is slightly upward sloping. And the correlation between previous experience and current salary surprised me when I ran the scatter plot, because it is downward sloping, which indicates that there is a negative relationship between the two. So I ran my regression, and these are the results. We can see here that the coefficients on gender and previous experience are negative, and the other ones are positive. My R square is 0.814, meaning that 81.4% of the variation in my current salary can be explained by my Y variables. And my p-values and my significance F all signify that these are statistically significant and that this is a good model to use to calculate or predict someone's salary. So, being female will cause a decrease in my annual salary by $2,255.03 per year. Education, having one more unit of education, will cause an increase of $590.39 per year on my salary. Having a higher starting salary will impact my current salary. So if I were to negotiate $1,000 more for my starting pay, that means I will have $1,723 more as my current pay. Previous experience, for each unit of previous experience, which I believe is measured in months as well, it will cause me to lose $19.44 per year on my current salary. Now, why that is, I have an idea. I believe that it is directly related to time on the current job, which is a positive coefficient, meaning it impacts my salary for the better. $154.27 per year for each 1 unit increase in time on my current job. So the more time I spend at my previous job, that means less time I can spend at my current job, and it will have a negative impact on my current salary. So at the 95% confidence level, yes, I have a good model. I also noticed, I want to talk about that intercept. It is negative. Now, it's silly to think that someone can earn a negative salary at any job. That just does not happen. But I do have an idea why that is. So, the best way I can think of that is when all X values are 0, one probably wouldn't even qualify for a job at this company. No experience, no negotiated beginning salary, no time on the job, no education, means you can't work here. So, if you do get a job, however, that automatically signifies that your starting salary cannot be 0, even if the other X variables are. So I believe that that intercept is the way it is because one of my X variables is beginning salary. So what does all of this mean? Is this a good model to apply to real life situations? Can we reject the null hypothesis? I would say yes, we can reject the null, that there is indeed a relationship between gender and salary and the other variables as well. So what does this mean going forward? Well, the data doesn't lie. That means that men at this company clearly earn more than women, all other things equal. I think a good start for us is we need transparency and wage disclosure. Point blank. If I am an employer, I would not only comply with transparency legislation, but also encourage open dialogue among my employees about their pay. This does not need to be a taboo topic. And when employers try to control their employees by making it forbidden to talk about their wages, people may not even realize they're being discriminated against by earning less than their coworkers. So we need to open up the books, let people know what they're making, and this will help embolden women and others to fight for what's fair, either at the negotiation table or in the courtroom. So, in conclusion, not a perfect data set. Unfortunately, I didn't get any explanations on what my units of measurement were for some of the variables, though I suspect that they were in months. If I had to do it over again, I would make a few changes to make it a little easier to interpret and apply to real situations. I would make sure that the units of previous experience and time on the job are in years instead of weeks or months or whatever units they are currently in. And I would convert units of education to a ranking system instead of whatever it is now. I believe 12 is high school degree, 15 is college, 16 is master's. It's not readily clear by looking at the data. I would change it to 0 is high school, 1 is bachelor's, 2 is master's, 3 is doctorate degree. And the original model had the birth dates for each employee. I would add back in the ages, not the birth dates, convert them to the ages, rerun the regression to see how age affects your current salary. I think that there would be a positive relationship there. And I would also rerun the regression with a dummy variable for minorities to spot any potential racial bias in the salaries. I think it would be more comprehensive in that manner. So again, data wasn't perfect, but it was informative and it successfully answered the specific question I asked regarding the gender wage gap. It was also a nice sample size and relatively logical. And I am overall satisfied with the statistical significance of the results at the 95% confidence level and even at the 99% confidence level. So again, thank you for listening to my presentation, and that is all.